Hello everyone, this is Teacher Justina and welcome back to my channel. And then if you are still new, then do not forget to like, subscribe, and do not forget to hit the notification bell for more video updates. Our video for today is all about factoring polynomials with common monomial factor. Okay, but before that, we will be recalling what is the greatest common factor or the known to be GCF. So what is the greatest common factor? So GCF is the largest of the common factors of two or more numbers or expression. Okay, so let us have this. We are going to find the GCF of the following pair of numbers. So we are given 10 and 20, and first we need to get the factors of 10. So 10, the factors are 1, 2, 5, and 10. While 20, its factors are 1, 2, 4, 5, 10, and 20. So let us try pick their common factors. So we have 1, the 1 is common to the 2. The 2 also is common to 10 and 20, as well as 5, and then 10 is common to the two numbers. So among all the common factors, the greatest is 10. So therefore, 10 and 20 has the GCF or the greatest common factor, which is 10. Let us try this number. We have 12 and 6. So therefore, the 12 has its factors 1, 2, 3, 4, 6, and 12. While 6 has 1, 2, 3, and 6. So let us try see their common factors. So 1 is common to the 2, as well as 2, then 3, and then 6. So among all the common factors, 6 is the GCF. Okay? So let us try this. We are to find the GCF of 4, 8, and 12. So that's time there are three numbers already. Okay, but before that, we are going to recall the so-called prime factorization. So what do you mean by prime factorization? So when we say prime factorization, it is a process of factoring a number in terms of prime number. But what is a prime number? So when we say a prime number, it is a number that have only two factors. It's only one and itself. So let us have the GCF of 4, 8, and 12. So again, we will be having its prime factorization. So let us try have first the 4. So the prime factors of 4 are 2 times 2. And so far, 2 is already a prime because it's only 1 and itself 2 are the factor. So 2 is already prime. So next, the 8 has its prime factors 2 times 2 times 2, and it's 8. Then the 12, we have the 2 times 2, which is 4, times 3, which is 12. And then for that, let us try see their common factors. So among the three numbers, 4, 8, and 12, the 2 is common. And then still, the other 2 is also common to the three numbers 4, 8, and 12. And then for this, what shall we do with the 2? Then so far, um, our GCF is 2 times 2 is equal to 4. So the GCF of 4, 8, and 12 is equal to 4. Okay, let us try this numbers 15 and 27. So 15 and 27 has its prime factors. So 15 has 3 times 5. Again, the 3 and 5 are already prime. While 27, we have 3 times 3 times 3. Thus, it's already 27. So among the two numbers, 15 and 27, only 3 is common to the two. So for this, our GCF of 15 and 27 is only or is equal to 3. So the GCF of 15 and 27 is equal to 3. Okay, so this time we will be getting the GCF of the following expressions. And this time, this number one is literal factors. So when we say literal factors, a variable is being raised to a certain exponent, and this exponent is telling us that the variable is being raised to n power. So what is the GCF of x to the 4, x to the power of 2, and x to the power of 5? Okay, so far, the best thing to see there or to examine is to find the the expression with the least exponent. So therefore, x to the 4, x to the 2, and x to the power of 5, it's the x squared is the least. It's the expression with the least exponent. So therefore, we have x squared as our GCF. Okay, and let's proceed number 2. So far, we have the x to the 4y squared, x to the 5y to the 4, and x squared y to the power of 6. So far, we have more than one base, which is the xy, and the xy on the third term. So, so far the x is common and the y is common. And we will not write the xy alone, but only we need to see to it that as we have done in number one, it is said that the expression with the least exponent is our GCF. So for the x, as you have seen, we have this as a 4, we have this as 5, and we have this as 2. So for the x as a variable x, so what is its GCF? It's x squared. Okay? And then for the y, as you have seen, among all the variables y with their exponents, the 2, it's the 4 and the 6, so the least there is the y to the power of 2. So overall, number 2, our GCF is x squared y squared. Let's proceed to number 3. Okay, number 3. Okay, so far we have already terms which is a combination of a constant and a variable. So our constant this time is other than 1. Uh, it's not same with number 1 because our numerical coefficient or our constant there is understood a positive 1. So number 3, we have already a numerical coefficients 15, 3, and 27. So for that, we need to see to it that we need to get first the GCF for the constant. So among 15, 3, and 27, what is the GCF, the greatest common factor? Remember, when we say greatest common factor, it's the common number. Uh, it's a number that is common to the three, and it should be the greatest. Okay, so far, a 15, a 3, and a 27, its greatest constant factor is 3 because 15 can be divided by 3 and a 3 can be divided by itself while 27 is also can be divided by 3. And do not be misled of the concept. When we say GCF, greatest common factor, it's not that we have to consider the greatest common constant or the greatest common number, but it says that when we say greatest common factor, it's the common to all numbers in the given, and so for that number can divide all the constants in the given. So we're done. 3. While the variable, which is x, And the least exponent among the three, which is 4, 6, and 5, the least there is x to the power of 4. So therefore, the GCF of 15x to the 5th, 3x to the 6th, 27x to the 4 is 3x to the power of 4. What about this number 4? So as you have seen in number 4, we have the 4, the 12, and the negative 18. So far, the 2 is the common to the 3 rather. So because 2 can divide 4, and 2 can divide 12, and 2 can divide 18. If you will say 4, maybe you will be saying why it's not 4, in which 4 can divide 4 and also can divide 12. But remember, 4 cannot divide 18. It can divide 18, but it's not exact. There will be a remainder. So when we say greatest common factor in relation to the constant, there should be no remainder other than 0. So therefore, among the 3, 4, 12, and negative 18, only 2 as our GCF. Okay, but what about the variable? So you try C, we have C squared, we have K to the 6, and we have X to the power of 4. So the literal factor or the variables don't have any common. So therefore, our GCF is only the constant 2. Let's proceed to number 5. So number 5, let us try examine their constants and 6 and 7. But I'm sure there's none. There's no common factor in the numerical coefficients. Thus, let us now go to the variables. And so far, the m squared n cube is common to the two terms. So therefore, it's a common factor. So m squared n cube. Let us try have this number 6. So for number 6, we have to have the 5, the negative 5, the negative 25, and the negative 15. So I think this is very evident that the negative as a sign is already common to the three constants, and so far the 5 is the common factor of 5, 25, and 15. Again, negative 5 can divide itself. Negative 5 can divide negative 25. And that negative 5 can divide negative 15. Therefore, we are done with the constant as the common factor. Let us now have their variable. So what is the common? Um, the common in h cube, h to the 4, and h to the power of 2. So among the three, h cube, h4, and h squared is the expression with the least exponent. So therefore, the GCF of this number 6 is negative 5h squared. Okay, so let us proceed. This time, we will be getting the factor of the following polynomials with common monomial factor. So when we say common monomial factor, it's that one term that is common to the given number of terms. So therefore, what is that common monomial factor to the given 9x plus 27y minus 81z? So therefore, we have there the 9, 27, and 81 is to be considered first. And for that, for the constant, we have a common factor, which is 9. And since we will be getting the factor, we should have to prepare two sets, no? So when we say what should be the number multiplied to 9 in which the answer will be the terms inside the parentheses. So therefore, what shall we do with that 9? So that 9 will divide to the first term, which is 9x. So when we say 9x divided by 9, of course, the answer will be x. Because if we multiply back 9 times x, will gives us 9x. Next, what shall we do? We are done dividing 9x by 9. This time, we now divide 27 by 9. So 27 by 9, or 27 divided by 9, or 27y divided by 9 is equal to 3y, because 3y times 9 will gives us 27y. Then let's proceed. 81z divided by 9, of course, will gives us negative 9z, because negative 9z times 9 will gives us negative 81z. So therefore, I hope you were able to get the correct factors. So the factors of 9x plus 27y minus 81z is equal to 9 times x plus 3y minus 9z. Number 2, so 4, 8, and 12. So, of course, what is the common constant? The common there is 4. At the same time, why we have the c squared? Because the c is common to the three terms, and it is with the least exponent when we have the common from the variable. So 4c squared is our common monomial factor. So what are its other factor? So that 4c squared divided by our common monomial factor. So 4c squared divided by itself, of course, any number divided by with that same number will always gives us 1. And negative 8c to the 4 divided by 4c squared will gives us negative 2c squared, while 12c to the 6 divided by the common monomial 4c squared will gives us 3c to the 4. So again, if we multiply them back, or if we will distribute our common monomial factor to the three terms inside the parentheses, we'll be getting the given. Let's proceed to number 3. So the 3, 2, and 5 are our constant. But so far there's none. There's no common. And then for that, we have to try consider the variables. So the A, B, C is common to the three terms. But among the A, B, and C, A to the 1 and B to the 1 and C to the 1 is our least, no? Is our variables ABC with the least exponent. So therefore, it's the ABC as our common monomial factor. And what is its other factor? So we are done getting the common monomial, which is ABC. So 3ABC divided by ABC will gives us 3, while the negative 2ab squared c divided by the abc, remember, we'll be getting a negative 2b because there is a b squared. So if you will recall um the division, the power, the law of exponent, we have to subtract the exponent if we were be dividing common base. While the third term, 5a squared b cubed c cubed divided by abc, our uh, third term is 5ab squared c squared. And then so far, is there any still common in 3 negative 2b plus 5ab squared c squared? There's none. So therefore, this is considered as our, or this is already our final factors. Let's proceed to number 4. Number 4, we have 12x cubed y squared and then z squared. And then for that, our common constant there is, of course, the 12 and 24. It's 12 for the constant, while our x, y, z is also common to the true terms. So solve for x cubed and then x to the 4. So with the least exponent x cubed. And then for the y, among the three, the y squared, the y cubed. So y squared is the least. While in the z, we have the z squared. So for that, we are done having our common monomial factor. So what is its other set? So this given 12x cubed y squared z squared is exactly the same with our common monomial factor. So therefore, it will gives us a 1. While 24x4y cubed z squared divided by this one, 12x cubed y squared z squared, will gives us positive, uh, positive 24 divided by 12 will gives us 2x already. Why 2x? Because 24 divided by 12 is already 2, and then x to the 4, x cubed, will gives us x uh, already, while the z squared divided by itself will gives us a 1. So therefore, our factors of our given are 12x cubed y squared z squared times 1 plus 2x. Well, let's proceed to number 5. So 13, 39, and 26. Of course, our common constant is 13, while our variable, we have m squared as the variable m with the least exponent, so 2. So the n also among the three, n squared is the least. So what is its other factor? So we have 13m to the 4 n squared divided by our common monomial factor. So the remaining will be m squared already. So therefore, let's proceed the second term divided by our common monomial. So 39 divided by 13 will gives us a 3. And so far, we have the m cube n cube divided by m squared n squared will gives us 3mn, because if we multiply this 2, it will gives us 39m cube n cube. And then the last term, 26m squared n to the 4 divided by 13m squared n squared, this will be our uh, answer. So therefore, that answered number 5. Okay, so let us proceed. So number 5, we are given these two terms, 5 times the quantity of x plus 1 minus 25 times the quantity of x plus 1 to the power of 2. So far, let us try check their constant if there is any common. So 5 and 25, of course, the 5 is our common factor to the 2. So that's it. And as you have seen, each term has a quantity of x plus 1. So the quantity of x plus 1, and there is an x plus 1 in the second term. So for that, we consider that quantity x plus 1 is common. So far, the x plus 1 here has an imaginary exponent of 1, and in here we have a 2. So as we have known, it's with the least exponent, so will be our common monomial factor. So the 5 times the quantity x plus 1 is our common monomial factor. So what is its other set? What should be multiplied to 5 times the quantity of x plus 1 in order to get the exact given? So therefore, let us have this 5 quantity of x plus 1 will divide to itself. Again, 5 times x plus 1 divided by itself, of course, we answer it 1. So next, our second term, which is negative 25 times x plus 1 quantity to the power of 2 divided by 5 times quantity of x plus 1 will gives us a negative 5. because 25 divided by negative 25 divided by positive 5 will gives us negative 5. And remember, this quantity of x plus 1 to the power of 2 divided by quantity of x plus 1 to understood power of 1 will gives us x plus 1 quantity to the power of 1. So therefore, these are the factors of number 5. To proceed, let us have number 6. Okay, I just want you to try check. So as you have seen, we have two terms. So for the constant, we have there 12 and 8. So we have negative 12 and we have there a negative 8. So far, for that, let us try consider. We have here the c minus 2 and the 2 minus c. So if you will try think, is the c minus 2 or the terms inside this parenthesis, are they still common? Now we can only say common if and only if they are exactly of the same sign. So the c here is positive and the c in here is negative, while the 2 here is negative but the 2 here is positive. So actually they are not common, but still we can transform them into something that they will be or we will be coming up to a common. Okay, let us try make a certain transformation. So far we will be rewriting negative 2m cubed and the c minus 2. And then we have to rewrite the negative 8m to the power of 5. And then what shall we do with the 2 minus c? We will be adjusting this 2 minus c in such a way it will be in this format. C as our variable should comes first, followed by a constant. So how? So that will be in this manner. So remember that originally our C there is negative. So we will be having as our negative inside this C minus 2 quantity. So therefore, are we changing the the value of the negative C? Remember that if negative here multiplied to C, we will still come up with the original negative c. And then remember that the 2 here is positive, thus that negative multiplied to a negative, we will come up with a positive 2. Actually, we are not changing the value of the 2 and the c. They are still of the same if and only if that negative will be then distributed to the terms inside. So as you have seen, we are now having c minus 2 as well as in here the c minus 2. So what shall we do next? We are going to still to uh, so to avoid something which is quite confusing, we will be multiplying that negative sign with the negative in the 8m to the power of 5. And that becomes negative times negative, we have a positive 8m to the power of 5. And then we will be attaching the c minus 2 already. So remember, we were able to isolate the negative. We have to multiply it with the negative in here because this is understood to be multiplied to the terms inside. So therefore, are we already adjusting them in such a way that the the variable or the expression next to the 12m cubed and next to 8m to the power of 5, are they already common? Yes, they are already common. So let's proceed to getting the common monomial factor. So the common monomial factor, so we have 12 and 8, so therefore the common there is 4. And of course, the least exponent is m cubed. That is why we have 4m cubed as our common monomial factor. What about the c minus 2? Is it still common to the two terms? Yes, it's common to the two terms. So therefore, our common monomial factor is 4m cubed times the quantity of c minus 2, and which is to be multiplied to the other factor, which is this one, negative 12m cubed times the quantity of c minus 2 divided by this entire common monomial factor, 4m cubed c minus 2, will gives us a negative 3. Okay, so again, negative 3 times this will gives us negative 12m cubed c minus 2. And this second term divided by 4m cubed will give us negative 2m squared. So therefore, there's no c minus 2 already inside this grouping symbol because we have already the c minus 2 in the common monomial factor. So guys, I hope you learned something from this video. I hope you enjoy watching and you have learned something. So I hope before you will be ending this video, I hope if you are not yet done subscribing, please do subscribe. And this has been Teacher Justina and telling you God bless us all. Goodbye, everyone.